I'm on. Okay, cool. So everybody, very nice hello to Sunday evening for the final part of our hackathon, where we will have teams presenting their solutions on the sustainability challenge that we presented. Let me just quickly explain what will the judges be looking at in every solution. And of course, the best team who will get most points from each of the categories we're judging will win and get maybe some nice prizes. So first one is the impact on environmental sustainability, how the solution address that. Then does it address maybe social sustainability, economic sustainability? But very big part is, of course, the innovation you're showing, the method. Do you leverage the right kind of data? Is data biased, non-biased? Is it addressing sustainability challenges? Then, of course, we will look at the architecture of the solution, and we will also look at how easy it is to operationalize the solution. So, can it be brought into the production not with too many difficulties, or is it just not ready for that yet? So this will be basic judging criteria. There will be 3 judges judging that. Of course, you can ask questions and so on. But anyway, good luck with your presentations. So Kuba, please invite the first ones to the stage.
Okay, so the first team is Next Convulsion. Welcome.
Hello?
Hello.
We were suppressed? What happened?
It's on default, but it's okay. Oh. Okay, they came back. Wait a second. Okay. Okay.
Can you hear me? Yeah, I think so. Yeah, probably because... No, she should. I will... Yeah, because it appears like you have to click something and...
Yeah, I have no idea. Ah, okay. Because it was just falling all the time. We were trying to connect and it just kept falling.
Yeah, can you see?
Can you see us?
Okay.
Yeah, all good.
Then we can start.
Hi, Kuba. Okay, so. Wait. I can't see your screen. So I'm having a few issues sharing screen, so Diego will be sharing, but I can't see.
We can see our presentation. We can see our PPT.
Okay, you can see? Okay,
Yes.
fantastic. Fantastic, great. So, first of all, thanks everybody for being here. It's been great fun actually coming up with ideas for this hackathon. Diego and I actually got together and we started thinking about ethical AI in decision making and how it related to the other topics of sustainability. And one of the topics we chose was food waste at home. So, first of all, we would like you to meet our good friend Eva. Eva lives at Erdstrasse 7 on the 5th floor. She is a 30-year-old single working mom. She has a great relationship with her neighbors. She has lots of fun with them. They support each other. And one of the things they often discuss is the incredible amount of food waste that they have at their place. Either because they buy too much and they can't finish it on time, or because they buy something that their child liked and then all of a sudden the child doesn't want to waste. for several reasons, there's a lot of waste. Okay. Would you mind switching the slide, Diego? And amongst their conversations, they decide, what could we do together to reduce food waste? What if there was a way that we could see which waste we have in exchange? There are several things similar in the house, like, for example, Too Good to Go, that the supermarkets, they put their waste there. What if you could do it just, within our building, within our neighbors? And that's why we decided to create, if you could change the slide, please, our food exchange app. So food exchange app is it's an app that would allow you to know what everyone bought in the supermarkets and how much they're using. It could predict everyone's waste and allow you to ask to exchange food before it's wasted. And it's a way to fight waste as a group with your neighbors. So basically it's an app where you would register either manually or by just scanning the receipt of your supermarket app, and it would be able to predict your consumption and which of your neighbors too would be able to switch. Do you mind continuing? And now Diego will explain exactly how the app would work, since the idea is that it would be able to predict your consumption and also the people you'd be able to exchange with. Diego, take it away.
Yeah. Hi everyone. So let's start by talking about a bit how the information would flow in such a system. So we have our user, which is supposed to periodically add his shopping list to the app, and this system could also be done through OCR, just scanning the receipt. And then the system should start taking into consideration this information, and it should start thinking about when the food that the user has added might start to go bad. And so the system notifies the user and says, well, you might have something that might be going back. Do you want to share it? The user can confirm this hypothesis. And in this case, the system replies with a set of users, which are supposed to be of other users, which are supposed to be near the original user. And based on these other users' habits, eating habits, the user should find those which might need the most the stuff that he has in excess. So a possible system for this application could be this one. So we have our user interfacing with an app, and in the backend we have a lot of other systems which take care of all these parts. For example, an important part is the user notification. How do we know that the user might have stuff that is going badly? Well, we could use a production rule system which listens to the information that the user is adding to the app and then the backend database. And this rule system could place deadlines for food expiration, taking also in consideration, of course, food typology, but also user information like his family size. Now, to the most crucial part is how do we predict which user is most likely to need the stuff that the user which is offering has to offer. And so we have to devise a system which, given a set of users and their purchase history, predicts what they will need and match the user's offering with those needs. And this can be done through time series forecasting system, which, based both on the user's history and the general population trend, forecasts what the user will need in the future. And this trend can be learned with deep learning techniques, so a neural network. In our small implementation, we actually implemented a small neural network which works on this dataset called simplified Instacart. And it was just what has been implemented is quite a simple structure. So something like an autoencoder, which, given a lot of orders, encodes them in a low dimensional space, and from this tries to reconstruct what the user might need in the future. Now let's look at a small demo. So can you see the entire screen? Yeah. So we start with the main page of our app, which tells us that the user might have something to share. And this is by going to the share food part. The system has already processed all the similarity between this user and other users and ranks them based on this similarity. Now, the user might want, and the user, of course, can see what was his purchasing history. So here we can see his purchasing history, and of course, can add the new grocery store trips by buying, for example, apple, yogurt, fruit dip sliced apples, or some cups dark chocolate, and register this list of new stuff. So this stuff is now added to what the user has previously bought. And now we can say that actually I want to predict which users might need this stuff that I have. So now we can, in this case, the prediction is handled by locally, but of course, in a real system would be handled on the cloud and periodically through this production rule system, which tells, hey, maybe it's time to do an update. And now we see that the similarity between this user and the others has changed. Yeah, sorry?
No, continue.
Now we can go back to our presentation.
I can talk about what our business model will be. Thanks, Diego, for preparing all of this. So, in terms of business model, for time constraints, I'm going to focus on what we thought would be the most important points. So, our value proposition is that this would be an app that would allow the inhabitants of a building to exchange their excess groceries between each other to save waste, which simultaneously builds community, right? Thanks to AI, they would be able to predict what waste you will have and propose with which of your neighbors to exchange. For instance, you have in a 2A, they like to cook a lot with carrots, but they always have a huge waste of asparagus. And in 5B, it's the opposite. They cook a lot with asparagus, but sometimes they don't cook so much asparagus, but they need a so they can switch between each other. It needs only a minimum of 2 neighbors to register to start this, right? So it really creates a sense of community as well. So who would our key partners be? Real estate agencies, for instance, they would have, whenever they would have a new building, they would encourage the neighbors to register for this app. Supermarkets, grocery stores, we could also incentivize them to that. Activities that we would use to promote, we thought about meetups and live demos. The customer relationship that we want to build is based on automated services to predict your excess consumption and exchange it. It's also based on building of community and co-creation, because you can either put it manually, your groceries, or you can just scan it. Our customer segment would basically be, buildings, neighborhood adults from 20 to 65. And what resources would we need? Mainly software engineers, servers, and staff. The staff would be mainly like marketing campaign managers and project managers. And the channels we would use most for our app would be social media, of course, and online and printed media. Our revenue streams would be mainly coming from advertisements, in-app advertisements, memberships. As it grows, we could actually create a membership for the buildings, and also from the partnerships with supermarkets and groceries. What we identified as main cost structure that most of our funds would go to would definitely be server maintenance, software engineers, specific ML and AI engineers, marketing campaigns, and staff like comms managers and project coordinators. And we really believe that we would have a big social and environmental benefit with helping reduce less home waste, the community building, and basically giving this feeling that you're fighting waste not alone, but together. Because one of the things that comes with sustainability is a lot of the people feel that it's overwhelming due to the information, to where to start. And this is a way to do it together. So I hope you've enjoyed our presentation as much as we enjoyed, you know, digging into this and creating our app. Feel
Thank
free
you.
to ask any questions. And big thank you to Diego.
Thank you, Gigi.
Fantastic work.
Hey
Thanks,
guys,
everyone.
so can I ask a few questions?
Sure.
Absolutely.
So yeah, this is really interesting and it's really in the spirit of what we wanted to see. Uh, just maybe a short clarification from Diego, if possible, around the architecture. You mentioned a little bit, and maybe about the operationalization. How do you envision that? Or, maybe just you said you're using a encoder-decoder model, but maybe you can tell us a little bit more about the training and everything that you did. Thanks.
Yes. Sorry, operationalization, you mean?
How would you make it live? You said you would bring it to the cloud, but could you maybe say a few words more about that? I see it's running on your local server, right?
Yeah, of course. So about the architecture, uh, honestly, this is just a first idea. I've not dealt much with time series forecasting. So the idea is you have a list mm, of orders. That is, you know that the user has bought this stuff, this stuff, this stuff, this time, then this stuff, this stuff, this stuff, this time. So this is this is a series of time steps. This is then first of all there's a and it's really high dimensional since we have a lot of products and these products are one not encoded in a tensor, and this high dimensional representation, which is actually a time represent both a time and one not encoded representation. Um, the one not encoded dimension is then scaled down, which is then passed through a recurrent network to deal with this time, which is and the recurrent network use was by LSTM, and to extract temporal information. And this is then processes back to the high dimensional information that we had in the beginning. I'm not completely sure that's such a good idea, but for sure with more tuning, we could have something better. And as for operationalization, well, once you have a model, I imagine you can upload it on one of the many services like Amazon AWS and service the app effortlessly. Like you receive, you have a connection to the database which contains the previous user orders, all the users' orders, and then you can exploit this information, I guess.
I mean, just
Okay,
to add,
thank you.
obviously there are still a couple of details that we would need to think a bit more through and develop a bit more. Like for example, we want to, if it's vegetables, it would be difficult to have an AI that would predict when it would go bad, but we could at least have them predict the quantity based on how many times the person buys the same items. We could get the AI to predict their usage, their consumption rate, and that would help them see, would compare with the other neighbors and predict the exchange, how they could exchange, with which neighbors they could exchange.
Yeah, sure. Great. Thank you. Questions from maybe Denis or Lucina?
Also had a couple of questions, if you don't mind. So can you talk a little bit more about how you're gonna track or predict consumption? Because I understand that you're planning to ask people to enter into application what they purchased or maybe scan receipts, but how are you going to understand what they have consumed, what maybe gone out of
Well,
date?
Yes.
our first idea was to, just with the simple rate of how many times they buy the same items. That was our first instinctive idea.
But
Would you
Okay.
then
like
also we have to
to?
consider the item itself, and each item is different. So maybe I thought that using a rule system might be useful to say, well, this stuff will go bad this time, and the rule system can take into account a lot of factors.
Mhm. Okay. And another question I had was, what data did you use for this solution or
So
prototype?
I used this dataset, simplified Instacart. So it contains we know that, for example, a certain user has made an order, and an order contains, and also we have temporary information, but it wasn't used in this mini project. Anyway, we
Okay.
know that the user has made orders, and the orders contains a certain set of products, and these products, of course, have names which are inputted through the app itself.
Okay. Okay. Thank you very much.
You're welcome.
Anyone else wants to ask questions?
If not, then thank you, team. The next.
Sorry, I have one small question. I was muted.
Answer.
May I? Yes.
Yes, please, please.
Yeah, just quick follow-up also to Dennis' questions. Like if I contribute to this app and have my checklist, how would the app know how much from that I consume and how much I throw away? Like if I order carrots and then next week I also order the carrots, but the previous one just get bad and I throw it away, and then now I'm ordering new one. How would the app knows that the other is not consumed?
Yeah, we would just the app only gives suggestions based on how much time has passed since the product has been bought. So unless the user itself inputs the information, it can't really know.
Okay, so it's based on the manual enter from the user.
Either manual could be another feature, manual entry, or it's just based on possible suggestions which the user can ignore.
Okay, because
So
some products. Yeah, please go ahead.
yeah, this is one of the aspects that we would need to dive a little bit deeper. But this was our first instinct. It could be based either when you enter it manually, you could put the date, or just based on the quantity. And it just okay. Of course, it would allow for a little bit of error in prediction, but at least it would be a start.
Yes, because
Or get
a lot of
consent
products have a different expiration date,
Yeah, that
right?
could be a feature that you could add. For instance, it could be we could make them scan the receipt or actually scan the package with the expiration date. That's something that we would definitely have to dig in a little bit deeper. But our first instinct was to start as easy as possible. Would be based on the quantity
Okay, thank
and the
you.
learning how much they're using. But there's many avenues that we could pursue to be more precise. Diego and I were discussing that as well.
Okay, thank you.
Okay, thank you a lot. Just to make sure your team name is the next convolution, right?
Yes.
Okay, good. Then thank you, team next convolution. I would ask you kindly to log off this channel that we can listen to another team. Thank you very much.
Thank
Thank
you.
you. I
Okay, the next team is Data Unicorns. Oh, okay. Hello, Murat. Can you hear us? Oh. The same thing happens.
Okay, do we have the next team on?
Yeah. The presenter is with us. Actually, I think we can hear him. Hello, Murat. Can you hear us? Let us know.
I'm
Please.
hearing you.
Yeah.
I don't know whether you hear me.
Yes,
Now we
we hear you.
hear you.
Ah, perfect.
Perfect.
I'm sorry, I was muted. Yeah. So we're ready
Okay.
for the next presentation.
So
Okay.
next presentation, Team Data Unicorns, right?
Yes.
Okay,
I'm
great.
sorry. I'm hearing my voice also.
Are you watching the stream?
Oh,
Yeah, maybe
So
sorry.
remember
mute
to
the
mute the
I'm
stream.
stream.
sorry. Yeah. Yeah, that's a bummer. So can you hear me now clearly?
Yes.
Let me
Yes.
check once again. Perfect. How about my screen?
You're not sharing the screen yet.
Just a second. Let me. How about now?
Yes, we see your screen.
Perfect. So, hello everyone. I'm Murad. Uh, First of all, thank you for everyone creating this opportunity. It's amazing. It was an amazing experience. Actually, to be frankly speaking, I didn't know how I ended up here. I just accidentally got an email that, hey, you have a scheduled hackathon on Friday. I was, oh my God, really? It's good. And I didn't know how I registered to your hackathon, but it totally worth it. Um, we had like 4 or 5 people, but I think we were like spread out all over the world. We have time difference issues, so like we couldn't communicate very well. But so I don't know what is happening with other guys, but I stick with the project, with the idea, and kept going on to do something. And I even like was quite stubborn. Like I was like last night. By the way, I'm joining you from US, so we have a like huge time difference. Like till last night till 4 a.m. I was like, I'm gonna finish it. I'm gonna do something at least. And so I don't know like where our rest of the team, but I will be joining. The name of the team is chosen by Carla. She decided to continue with her own team. And so yeah, today it will be only me, if it's okay for you guys. Our approach was, by the way, at the beginning of the presentation, let me explain that I have electrical engineering background also, and so I have been working in industry. I designed power plants, renewable energies, like mainly solar, hydro, and like involved in the operation of the power plants. So more or less, I know how the things works in the energy sector. And in addition to my graduate studies in machine learning, when I listened to the first day on the first day the presentations by Rock and others, immediately clicked me like about environmental sustainability, like to put some lights on this side of the work and use my past experience. My base idea was that apart from the normal like daily users, huge industries, big companies always makes pre-agreements, which is called PPA sometimes. So those companies always seeks financial efficient electricity buying, they can go to the fossil fuels because it depends, depending on the. By the way, it's heavily depends on the country regulations and everything. So, but this is the tendency of the companies. Let's say transformer manufacturers. They need huge ovens, 10-inch tall, and they consume a lot of electricity. So it's better for them to make rather than buying directly from the grid. They make a pre-agreement with the utilities or wholesale sellers and this kind of a company, private companies. So when they do that, mostly they seek their financial benefit rather than like being environmentally concerned. So I wanted to put light on this a little bit, like whether we can detect something. I came up with the steel industry, which is one of the main major carbon dioxide emitting industry.
Sorry to interrupt you.
You
one thing, we can't see your presentation. If you show something, we see the Discord tab.
Oh, really?
Yes.
Sorry about that. Let me try again. I'm gonna try again. I'm sorry again. Oh, okay. How about now?
Yeah, now it's working.
Perfect.
So continue.
I chose steel industry because it is it's one of the main greenhouse gas contributed to the environment, and they hold 8% of the CO2 emission. But in the meantime, from the financial point of view, that I wanted to make some combination. All the time, these kind of industries are looking for some kind of investment when they are even they are in the open market, or they can look for the private investor to enlarge their production companies or facilities. There are quite a lot of, for example, steel companies that follows the financial model that I mentioned just recently. They go after the financially beneficial consumption, electricity consumptions, rather than being environmentally friendly. I found this data from the Kaggle, and I put the reference on the GitHub for the link. This is the one of the steel factory. So again, I wanted to present you one example. And now imagine in the market let's say a hedge fund or investment company who has who is holding a lot of like thousands of the companies from different various industries, not just steel industry. It can be oil and gas, it can be petrochemical, this and that. So this is the one example as a prototype, and I found this data. Anyone who from the industry this knows that this is very clearly. It was not mentioned, but I am pretty sure that this is obtained from the SCADA historian. They have a consumption. They are like normally in SCADA you put like 15 minutes. Each 15 minutes you get the records from the field equipment or the tariff metering or any kind of the electronic device that supplies information. So we have those kind of basic information which can give us some idea. So this was our idea, how we can understand that whether there is some kind of relation between the energy consumption and the impact of their consumption on the environment. which can be directly or indirectly. Directly means that in steel industry, you can measure their let's say carbon dioxide emission from their furnaces, the blast furnaces. That's one thing. But indirectly is the one that we can. By the way, we can measure that, and we can put in our consideration in more detail in the full model, in the much bigger scale of work. But in the meantime, I would like to address the indirect aspects, as I mentioned, where if they buy from the near coal power plant, they're already burning coal, and instead, additionally, they go and buy the electricity from the coal. Or they bought the electric blast furnace, but still they go and buy electricity from the coal manufacturer. With the buying the electric furnace, they can, let's say, convince everyone that, oh, we are environmental friendly, but at the back end they might be using something not that good. So I first started trying to understand the daily usage of the electricity and of the power plant, and I will share another screen. Um, uh, um,
Now we just see your GitHub.
oh, okay, now we're good. Okay, perfect. I think now you see again another like sustainable AI hackathon series GitHub page. No,
Yes.
perfect. So after I obtained the data, I just run basic data inspections, like to understand what is data, whether there are like null values or like very simple basic stuff, and try to understand the correlation between the usage and emission. As we can see here, based on my previous experience, I was like pretty sure that there are going to be high correlation with the CO2. But again, this can be because we don't know the source of the data. Because we didn't obtain, we just got it from the Kaggle. This can be explicit reason of the CO2 emission. So I didn't want to come up with the conclusion, okay, they are very bad with the emission. But rather than I tried to understand the daily electricity usage of the company and try to find some kind of a pattern. So to do that, first of all, in electricity market, it is mandatory that you check everything hourly, not in general daily. So I started to understand their usage each day of the week, whether it is weekend or weekday. So this kind of I got this kind of a pattern here during the weekdays, and it can. What it got stuck me, that they didn't use the generally this kind of companies who are when you connect it, like when you have a huge load and when you have a capabilities, you mostly consume from the off-peak times, and it is more beneficial for you, costly, because it is very much cheaper than on-peak hours. So here, this company consistently used the peak hours times, and this got my attention again from the electrical engineering point of view. So what I know also that when you have a PPA and when you have a power plant, let's say, you don't want to when you have a big power plant, you don't want to switch on and switch off that. You want to okay, this is the time I can supply you this much during this time, okay, and so this is going to be our schedule. I got like that kind of feeling. For example, when I went to the weekend, which is the businesses are not operating that much, they loaded their the manufacturing. So I hope I believe that it's related with their electricity usage also at the weekend. Like for example, Saturday heavily. So instead of using keeping this at the minimum and going at the weekend at the maximum and or during the weekdays and buying at expensive rate, what I believe that they might have some fixed cost buying electricity buying, based on the PPA. So I have a PPA. I'm going to supply you electricity at this hour. So from there, based on this, so I decided that okay, let's bring in all the parameters from the data, but we cannot apply regression directly. So I have to the shrink down the parameters because of there are not real values in the among the data. There were a lot of categorical values. So I managed the data accordingly with the reach and prepare the data and run some training on the given the data that by the way our target value is going to be our electrical usage, and in the meantime our data set ranges whole year, 1 year, 365 days. Each day, each hour, every 15 minutes, the data is collected. So it can be some kind of a projection for the future. In case if the company has way more problem, not in case it's definitely there is information in the company that they have that kind of information for the past years. Also, this is they made only 1 year public, so we can use all those information and correlate with the electricity usage and start evaluating and trying to find a pattern of their electricity usage. Okay, a huge industrial potential of the buying a lot of electricity. They buy in the peak hours, so it might raise some question. So for the investment purposes, this was my my approach to like a very basic potential approach to detect something from the usage of the big industries. I'll like this. Of course, this is very primitive experiment within we come up with within the 2 days. We cannot claim anything about that steel company or anything. But I listened to your first day panel also. A general from the Seattle also Rock also mentioned in the chat room that the data, the collecting the data for the sustainability is very difficult. But for me, I always look from the academic perspective or the let's say finance industry, and I'm coming from the energy industry. I'm curious whether each side is communicating with each other very well, because what I know is that the automation industry is way much older than, let's say, big tech companies. in the same manner that you saw that the data, they are collecting data, they must collect the data for the automation system continuously every 15 minutes. And there are so many sensors in the field collecting information about the various parameters of the plant, of the facility, anything. By the way, it's not just households. It is the industrial facilities. So you have to do that for the safe operation of your plant, your business. And in the meantime, not only those data is used for the automation, they also is brought to the scale for the operators, and they are stored. And I know from my experience, each company when you build a facility, they require for the scale like 10 years of the storage, the data backup. So there is a massive data out there. I believe in let's say in various industries, not I would say I would call it like a hard industry, like not like a software industry or finance, that collected and sitting there. And I believe that it can be used and to get some kind of a patterns and about the industry, how can they improve their electricity usage, and how can they be how can they help the environmental issues with that data. So I'm much more optimistic than a gentleman from Seattle. I forgot his name. I'm sorry, but that we have huge potential data out there waiting for us, like logistically collect them. Someone, I don't know. It's not me. Maybe big companies, and can be used for the good benefit. Thank you, everyone, for listening.
Thank you, Murat, for your
Hello?
presentation. Maybe just a few questions from my side.
Sure.
I've seen you use the machine learning approach,
Yeah.
which of course in this short time is good. I see you restructure the
Yeah.
data really nice,
Yeah.
very
It
nicely.
was.
I was
It
just
was very
thinking,
difficult.
were you, of course, no, it's fine. So, but maybe just have you thought of using some deep learning approaches as well?
No, I couldn't jump on that. So, Mark, this was the issue for me. Like, I have lost a lot of time to come up with the data. Without the
Hmm.
data, like
Yes.
to come up any kind of idea is difficult. So I lost a lot of time to look for the data. I found this data instantly, but to like this data can be very misleading. We all know it can be very hypothetical. So I tried to empower that data with additional information. So I lost a lot of time to look for that, to find some kind of insight. So then I decided, okay, like in the beginning I was tried to go directly with the electricity usage and emission, and then I figure out that, oh my god, like those emissions can be explicit reasons, for example furnace blast. What about the implicit reasons that I mentioned, that's going in the background, that without domain knowledge you cannot understand that. So I tried. So then I shifted my approach. So I when I looked at the data set, I said, okay, this is the, the best way is the regression at the moment, and not the simple regression,
Sure.
because there was a lot of categorical data. So that's why. And I finished that last night at 4 a.m. with the US time, EST. I was like, okay, now I have to. So I didn't have time to go like a deep
No, no.
learning.
Look, don't get me wrong. Don't get me wrong. I'm just saying, I think recognize correctly that quality data is more important than a model
Exactly.
that may or not may be
Mhm.
good. So
Mhm.
that's why
Yeah,
I
but
like what you did with data and so on. So yeah.
yeah, it is doable. It is doable. As I'm gonna emphasize that there is a massive data that's sitting in the industries that can be used. The industries are the main reasons of the like one of the main reasons when you combine them. greenhouse gas emissions. So, and they have the data that they, for their sake of their businesses, they measure everything like analog signals, like constantly continuous signals they are receiving and they are storing it. And for everything, believe me, for everything, they are collecting the data. But it is, I don't know whether it is not known or maybe they are not sharing it or I don't know, like no one approached them. So just wanted to bring this to your attention.
Great. So any questions from Dennis or Lucina?
Nothing from me. Thank you.
Oh, thanks.
I think for me as well.
Oh, thanks.
Then thank you a lot, Mura. Yeah,
Thank you very much.
thank,
Again,
thank
I
you.
appreciate everyone's effort that was put in this hackathon. It was amazing.
Yeah, thank you. You too.
Have a nice day.
You too. Thank you, Murad, again, and thanks for joining.
Thank you.
Okay, so the next team is Data Phoenix.
Yes.
Hello, can you hear us?
Yes, I can hear you. Can you hear me?
Yes, yes, we can hear you.
Okay, now I'm going to present. Please let me know if you see.
Sorry, there is a lot of background noise.
Oh, maybe because I have my heater on because it's cold here. Can you hear me now well? Or is
Yeah,
too much?
this is a bit better, yes.
Okay.
Yes, and we see your screen also.
Okay. And can you see me? I opened the video, but I think the camera says it's
It's loading. Yes, we can see you.
Okay. Thank you very much. Well, I'll start if everything's okay. Thank you again for this opportunity. I had a lot of fun in this hackathon. I actually came from Reddit. I was subscribed to some Reddit subreddit and saw this and said, why not? And here I am. Okay. So, sorry, I forgot to talk about the title. I titled my presentation as Earthquake Guardians. It sounds really bombastic, but it's just a name. I thought if I have a good name, I could win. And it's about how to predict, of course, predict with earthquakes using deep learning and Twitter. So, I'll present myself. My name is Carla. I'm actually a scientist. I worked as a physicist for a long time, but now I'm gravitating towards data science. And my title of my job right now is a machine learning engineer, but I'm actually learning. So it's been a challenge, but a good thing. And my name is Data Phoenix because I was with Data Unicorns, but sadly, because of the time constraints, about time differences, time zone, we couldn't get together well, so I decided to continue my own, and that's why my name is Data Phoenix, because I was reborn from the Data Unicorns. So, did you know that earthquakes can be predicted? Actually not, can be predicted. So I always tell the story that, I don't know if you know this, but Chile is a very seismic country. We have a lot of earthquakes and they're normal. Actually, we have two words for earthquakes. We have temblor, which is a mild earthquake that doesn't bother you at all. And you look at the lamps and continue doing afterwards whatever you were doing. And we have the big earthquakes which are called terremotos. And yeah, so there are two kinds of earthquakes. Well, one time I was in Concepcion, which is south from Santiago, 400 kilometers, and where this big earthquake occurred in 2010. And I received a message from my mom telling me there was an earthquake in Santiago, a big one. I mean, not the big ones like terremoto, but a big temblor. And I said, oh, are you okay? And then a few seconds later, I felt the earthquake in Concepcion. So the message traveled faster than the actual earthquake. So in that sense, they can be predicted. You can know in advance, maybe seconds in advance, but you can know in advance if an earthquake is going to happen. Okay, so I lied. They cannot be really predicted yet. So this gave me the idea to use Twitter and deep learning to try to warn users about future earthquakes. I know that a Twitter solution is already being implemented. They monitor tweets for short terms, because people who are in an earthquake, they don't tweet a long tweet. They actually ask if there's an earthquake or just earthquake with a interrogation sign. And they look for short terms associated, at least in Chile, with temblor or terremoto, which are both words for earthquakes. But I want to combine, or at least that was my idea, to combine this with deep learning that tries to predict them. But how? How to do this? So, give me a second. Deep learning at least can try to predict. What I've read, I did a lot of reading about the existing solutions first, and I realized that they used neural networks, artificial neural networks, deep learning neural networks, to predict at least lab-generated earthquakes. They have labs where they take two similar to tectonic plates, and they put one to another, and they measure the shear and the stress, and they can fairly well predict these generated earthquakes. But I would like to use this kind of models to predict earthquakes in Chile. And how? By using an open database that was suggested in the Discord channel, called Grillo, or Grillo, maybe. It's an open database, and it's in real time. So every 5 minutes, they have devices that measure the acceleration in X, Y, and Z coordinates. And every 5 minutes is updated, so at least you have a 5-minute window, which you can do to alert people about it. So using that information that it's already there, it's in that database, I wanted to create a model that guesses when a future, or predicts when a future earthquake could occur. But what's the original thing? The thing is, okay, deep learning can try to predict, but you will have Twitter as your ally. These possible future predictions will be broadcasted through a Twitter account. Of course, the name has to be somehow not very alarming, because if you broadcast an earthquake worldwide and then it doesn't happen, people won't believe you afterwards. You have to subscribe to this channel knowing in advance that it's probably not an earthquake when it lets you know. And the users who are subscribed to this Twitter channel can confirm or deny this broadcasted prediction. This not only helps with early warnings, I mean, not only helps to know early in time if an earthquake is occurring, but also helps labeling the data, at least as a perceived earthquake magnitude for future predictions. So it helps the model to become better. It has feedback from the people. That's why, with a little help of my friends. And of course, at the beginning, this model will be awful. It won't predict anything, but it has to be iterated over time. I think it's just a matter of time. This model could be retrained using this feedback from the earthquake guardians, as I call them. and then become better each time. The model could be hosted in the cloud, and it could be automated using the tweets as labels, and retrain every month, or I don't know, it could be another time span. You just have to try. And since Reload database is updated in real time, the tweets it sends to the subscribed users will work in real time also. The tweets, the maximum time of delay would be 5 minutes. That I hope it doesn't work, but it's not like that. But at least it's a real-time database. I only researched this database. I didn't look at other databases, but it could. I think it could. They could complement this database. Okay, sorry. Sorry. Let me show you what I did very quickly. So I worked with the Studio Lab, and first I didn't do very much, to be honest, because of time and because of the time zones. There's a lot of difference. Actually, it's 1 p.m. right now here. And what I did basically was mostly exploratory data analysis, EDA. So I didn't do any model, but I researched about it so it could be done in the future. So I opened this database has a library that one can import from their website. I did, but this took me a while. I didn't realize that this took me a while because I had to downgrade here. I had to downgrade to a previous version for it to work. And I had to use some asynchronous thing to make it work because otherwise it didn't work. This took me a while to realize. And then you get the device. I use Chile, but there's also Mexico and some other countries. You choose a date. I chose a date and time that I knew an earthquake occurred, so I could plot it. And yeah, I looked at the database, some info, some analysis I'm exploring. And there you can see you have the X, Y, and Z accelerations you can measure. And if you plot them, you can see them here. So this is time, and this is the acceleration. And this is in the X direction, the Y direction, and the Z direction. And so it is possible to measure, to have the data, and to send it to Twitter if you can. I couldn't make a functional demo like the first group did so nice, but if I had more time, I probably could have tweeted something like the magnitude, and I could have tried to implement Python in Python some Twitter posting. Yeah, so that's essentially my idea. I didn't have much time to elaborate on it, but I think I did what I could in the time that I had, and I'm actually very happy just to be participating. So thank you for your attention, and if you have any questions, you're welcome to do them now.
Thank you, Carla. That was really interesting. I still don't know now after your presentation, can we predict the earthquakes or not? But the challenge was really cool. So yeah, I mean, I guess bonus points for using a SageMaker Studio Lab, and I guess the database that you use was also not one of the easiest ones. So yeah, thank you for your presentation. Questions from Denis or Lucine?
Yeah, just to confirm that I understood correctly, is the idea to predict based on the measurements from this open database, and then effectively test these predictions by posting on Twitter and analyzing feedback from people?
I mean, the feedback is you post it on Twitter, and if there's an earthquake, people will say, okay, it's true, there was an earthquake.
Yeah.
Let's keep in mind that earthquake is not something that you will die. At least in Chile, earthquakes happen all the time. And you are used to them, and it's something you are, oh, there was an earthquake, nice. I woke up and now I'm going back to sleep, you know.
Okay.
So people can confirm if there was an earthquake, a temblor. Let's talk about temblor, the smaller ones. So people can confirm if these small earthquakes are or true or not from the channel, and say, okay, the channel is correct, the channel is wrong, and then using this information, confirming or denying the information from the channel, you can apply labels, at least labels that say the perceived earthquake was from was big or small, because of course you have the magnitude, the real magnitude, the energy, the intensity, but what is important is not really the energy, because of course you have low surface or deep surface, but the perceived effects are the important things, at least to warn people about them.
So effectively using Twitter to label past occurrences.
Yes, and to warn people,
And then you can train model to predict better in the future. Okay, yeah, got it. Very interesting. Thank you.
Thank you.
Okay, Lucine?
No question from me.
Okay, so then thank you, Carla. Thank you very much.
Thank you.
I suppose you're going back to sleep, so we're going back
No,
to the
it's
net.
1 p.m.
Okay. Okay, so enjoy your day. Thank you again.
Thank you.
And we're moving to the last presentation, I think. So
Yes. So last team is Latebirds, and I'm pulling them to stage. Okay. Hello, Muhammad, don't press the button. Okay. Because Discord shows them like the big green button. Muhammad, can you hear us? Hello? We can hear you. Can you hear us?
Yes, I can hear you guys. Can you hear me?
Yes.
Awesome. Yes, I can hear you.
Okay, now I'm connected to it. Are you there?
yes, we hear both of you. There is just some background noise. Maybe one of you can mute that. But when you're ready, please start your videos and presentations.
Yes, I will start the presentation.
Yes, we can see your presentation. Feel free to share your camera also if you want.
1 second, so you can see me too.
Okay, great. We see everything, so I think you can start.
Okay, so hi everybody. We are the team Latebirds, as we were just a bit late for the event. I'm Joe, my teammate is Ali. We decided to go for the cybersecurity fintech track, but as sustainable as the other ones, but a little bit secure at least. Again, Ali is an AI engineer working for a company in Germany. I'm a young security analyst. I'm just 23 years old now, and I'm working in Switzerland. I'm also Swiss, and that's why I attend in this. And then I'm attending in here because I'm really eager to learn some new stuff, especially about artificial intelligence and machine learning or deep learning. I have some coding skills, but I want to get more into data science. Yeah. Ali, do you want to tell something about yourself?
Hi everyone, my name is Muhammad Ali. You guys can call me Ali. I am an AI engineer and mentor at DPS. It's called Digital Product School. It's the largest entrepreneurship center of Europe, based in Munich, Germany. I come from two backgrounds actually. I have a master's in finance and a master's in computer science, and I am really excited for my this hackathon. So, yeah, Joel, you can continue now.
Okay, so the objective in the cybersecurity and fintech was to detect the scam or fraud coins, tokens, or we went for transactions because we didn't have had a lot of time and issues finding right data. So we began by looking for data, could have been used to detect some malicious activity regarding blockchain or cryptocurrencies. And so we found an elliptic data set that contained blockchain transactions, some of which were legal and some of which were fraud transactions. And so we explored the data, made some visualizations to gain insight, and created then a machine learning model and developed an app. This is an example visualization you can see here. And the orange chart or the orange line displays the amount of transactions which appear to be legal and the blue ones which appear to be fraud. This was already pre-defined from the dataset we got. And this whole dataset is from a time period of around 92 weeks, like 1.8 years. So it's quite a long period of time. Each step equals 2 weeks. So it's a long period of time we can see here. We don't know which year exactly this is, but this doesn't really matter for now because data is reference labeled and usable for our training model. Yes. So Ali, would you like to tell something about the application?
So, I hope you can see my screen right. My screen is visible. Yes, you can confirm my screen is visible, right?
It's loading.
No, it's still loading. Yeah.
Yep. Let me share it again. Now it is visible, right? Awesome.
Yes.
Awesome. Okay, so regarding the app, I'll walk through with the code and the app as well. We deployed the app, but before going towards that part, a little bit of theory. So we have used AutoML and we have used PyCaret. It's an open source low-code machine learning library that allows you to automate the machine learning workflows in a very simple sense. It allows you to train 10 plus models in just one go and with very simple methods. I have also mentioned the documentation link in my slide, so I'll share the slides with you guys so you can visit the documentation as well. Regarding the model, so I have used random forest. The particular thing behind selecting random forest and not going towards training and testing 10 plus models was the time factor and plus the advantage advantages random forest offers us. So random forest offers highest accuracy in all the classification methods, especially belonging to the tree side, not the neural nets, but the tree side. But I have also went through a reference, and they have used a neural net, and random forest is giving more accuracy than the neural nets as well. Regarding the technique, so it can handle big data thanks to the forest architecture, and it can automate assets. I have also mentioned a link of Corporate Finance Institute reference if you want to read more about random forest stuff. Okay, then. So let's move towards the app framework. So I have used Streamlit. Streamlit is again an open source app framework. It is completely Python based, and it is made in such a sense in keeping machine learning engineers and data science teams in mind. So it allows you to quickly create applications and deploy them on cloud without a much of hustle of web development and front end and back end experience. Okay then, regarding the URL, so this is the our app URL. Okay, and I am going to share this URL with you guys as well, if hopefully I can. I have no idea how to share it here, but yes, here is the show chat. So I can share the app link in the chat, and you guys can also visit the app by your own self. Okay, I hope you guys will find the app link. So here's the app. So yeah, so you just have to open the app in your browser and it will load up. It is hosted on Streamlit Cloud, again free of cost without paying a single penny, and all the files are like all the stuff is in Python, pure Python. I'm going to walk you through the code as well. So here's the app. Okay, so it is a simple classification application, but the important stuff is that it is built on Bitcoin illicit transaction, and the data set is provided by Elliptic. It is a London based blockchain analysis provider. So how does this app works? So here you can see it says drag and drop file here. I have a GitHub repository as well. I've shared the link in the form as well. So here I have also mentioned in the datasets directory a sample dataset with which you can try here to play with the app. So you have to upload your dataset here in the drag and drop file here. So I am going to try this out right now. Okay. So here is that sample dataset. I have simply cloned the repository here. So what I'm going to do, I'm going to upload the dataset here. Here my dataset has been uploaded to the cloud, and then I'm going to click on the predict button. When I'm going to click on the predict button, what it has done, it has used the random forest classification model that we have trained, and then applied inference on the dataset. So here, when I'll click on this button, download generated output CSV, so it is going to generate the output CSV. I've already played with that. That's why you can see this two thing. But if you open up this output data, I hope you can see my screen, right? Are you able to see the Excel file?
Yes.
Awesome. So here you can see the labels and scores. So what I have done in the sample data set, let me show you the data set as well that I have used for sampling. So here's the sample data set, and that data set lacks the important part. The important part is the scoring and labeling part. So here I have used the result, but behind the scenes our model have already like taken out this result thing. So it is a pure trainable thing, and then our model applied the inference, and what it did, it uh, gave labels to each record of or each row, and then the score, like how much confidence that model has on its inference. Okay, so I'll also give you a little bit walkthrough of what this means. It is categorical, like 1 and 0 means, and it is simply a percentage score, right? Either 100% the model is like confidence, confident, or the 94%, and the stuff goes on. It was just for the sampling purpose. That's why I have used just the 5 rows. Okay, so this is how the app works. Now, regarding the code, so since the repository is in public domain, so I can share it here in the chat as well. Okay, so here is the repository that contains all the files that we are going to need in our project. So it contains the dataset directory. In the dataset directory, I have uploaded the zip file of the dataset, and plus I have uploaded the sample test.csv as well, so that you can play with that. Furthermore, I have made sub data sets like xtest, xtrain for training, and ytest and ytrain for testing. So like xtest is the trainable parameters, and ytrain the labels, and so a little bit confusing, but xtrain and I hope you got the idea. Like xtrain and ytrain, simple trainable parameters and the trainable labels, and then xtest and ytest. Xtest for testing, and ytest again for like checking the metrics, like how much the accuracy is. But PyCaret works a little differently. I'll show you how. So here is in this directory our model like resides, and here I have uploaded the image of our app. Okay, now here is the eda.ipynb file. It's a notebook. This notebook contains all the exploratory data analysis that Joel has done. So Joel, would you like to give us a walkthrough of eda?
Yeah.
Okay, so
And
should
let's,
I so would you like to share your screen, or should I share my screen?
could you just open it, please?
Mhm. Okay, so let me open it in my PC, and you can give us a walkthrough.
Yes, there's just there we installing the requirements. There are just some basic visualization libraries have been used, like Matplotlib, Seaborn, and NetworkX also for some minor stuff. And more below, there is a chart I displayed on in the presentations. The number of transactions in each time step. This is the total amount of transactions we have per step, and below the steps by classified for legal and illicit transactions. And then we see it's quite unbalanced because we have a lot of legit transactions and a lot of fraud transactions. Ali was luckily able to handle this imbalance data set. And this is just also a bar chart from the line chart. And at least in the end, there is a correlations of bad transactions, like how many bad transactions were executed, which correlate to each other. Were there many single fraud transactions, or were there grouped fraud transactions, which correlate to a group of users which use it, or users or gangsters which work together, or more single. Yes, but
Awesome.
the statistics were also quite new to me. I didn't have much experience in it, or do not have much experience in it, but that's what I could do. Yeah.
Awesome. Awesome. Again, okay, coming back to me. So thank you so much, Joel, for the walkthrough on EDA. And now here comes the electric notebook. This notebook contains the code used for training and then making the predictions with random forest for the testing purposes. and then here's the stringlet underscore app.py. So this Python script contains the app logic uh, that is making sure this user interface and everything, the functionality is appearing and displaying correctly. Okay, so regarding the code, so this code is like made and tested on Kaggle notebooks. Here you can see, here is the notebook on which like I have played with this data set and then created the random forest model. So here basically we are fetching the data, and here we are pre-processing the data. Here you can see there are actually in the real data set there are three classes, but so the three classes are like illicit means illegal, then licit or legal, and the third one is unknown. So what we have done, the number of transactions were enormous, so we don't lack the thing with data. So we have enormous data, so that's why I've removed the unlabeled part and only selected the labeled data part. So then we have simply appended the call string as a prefix to each column name. Here we are reading our CSVs. This is the classes and this is the features. The names are very explainable, and then we have made complete data. Okay, and then we have added the result after ignoring the unknown part. Okay, so result is basically representing the classes, whether licit or illicit, right? I have then used the value counts in order to count the number of values in the results part. um, Here it should have shown, yes. So here you can see, here it is showing 42101, like 1 means like um, uh, it is licit or legal, and 0 means like 4545 records means illicit. So it is a highly imbalanced data set, right? Then I have just used head in order to check the first five records, and then uh, I have divided the data set into trainable and testable data set. So we have used frac equals to 0.8, means 80% of the data will go towards the trainable part and 20% will remain for the testing part. Okay, and here you can see the shape of the data. So for the data for modeling, means for training, is 37,251 rows with 168 columns, and then unseen data for prediction is 9313 rows with 168 columns. Here I am installing the dependencies that we require, and then I have simply imported the PyCaret and pandas package. Then here is the important stuff starts. So here the PyCaret starts its work. So PyCaret requires a setup method to be implemented, which creates an environment sort of condition for PyCaret, and in that environment we have passed on, okay, this is our data that we want to work on, this is the target column that we want to apply our inference, which is result. We want to normalize our data set, and the normalization method is use min-max, and we want to use transformations. We have used GPUs. You can use GPUs on Kaggle as well, and plus you can experiment. PyCaret allows you to use MLflow on the backend to log our experiments. I have named experiment, my name, like experiment name is as elliptic 1, and here's the fixed imbalance equals to true. What this parameter is doing, if it is set to true, it will ask you a question like logically which imbalancement method you want to use here that can fix this stuff. If you don't give any imbalancement method explicitly, it will go for smooth, which is an imbalancement tackling method, which uses resampling in order to fix the imbalancement. I have here opened up my like the PyCARET official documentation, and here if you will just search fixed imbalance, it will give you the parameter information here, and you can read it on your own whenever you get time. Okay, so coming back to the code, here here's the code. Then here um, so then here I have used create model. It is again a method in order to create a model. PyCaret allows you to use 10 plus models. I went for random forest due to time limitations, but random forest gave us quite a good accuracy. Instincts box. Okay, so I have used k-fold as 5, and this round equals to 4 means that for each metric give the result up to 4 decimal points. Okay, so here you can see for each fold these are the metrics for our random forest model, and here it is showing in yellow, which is a little less for the visualization point of view. So that's why I'm printing here so that you guys can see like the mean accuracy is 98.88%, which is quite high. Okay then, so here I like here you can print your random forest model as well, which will simply print it out for you. It is using scikit-learn, like PyCaret is using scikit-learn behind the scenes. So here is your scikit-learn model, random forest classifier. Then I we can plot a confusion matrix as well in just a one go using plot model method. And then I have saved the random forest like my random forest model with the name random forest v1, which you guys can find here in the model directory. Here the pickle file of my model is available. Okay, coming back to the notebook. So here I have used predict model method provided by PyCaret. So what it does, it requires you to pass the model, and then I have also mentioned that whatever the result you will give, please round the numbers to up to the 2 decimals. Okay, and then what it will do, like we saw in our application part, that it will behind the scenes it was giving like it was giving the result of only 2 columns, labels and a score. But what actually it does here, so what actually it will do, it will append these 2 columns to the data set that you will pass on. Okay, but one question here you can ask is like we do not see any data set passed, so the how PyCaret knew like which data set has been passed?
Mohammed, can you ask you one question? Could you slowly start bringing us to the conclusion, just because of the time? Otherwise, thanks for your explanations.
Yeah, sure. So in conclusion, I'll just explain the Streamlit code and why we went for this thing. Okay, so Streamlit code is the code that is powering this application, which I have to reload. So how does this work? We are using simple predict rating function that I have created, which using simple Python, nothing fancy here. Streamlit is just a Python based framework, so it works like a Python library. So you can import methods using Streamlit, just like you do in Python. Then I have simply loaded my model. I have mentioned the path, and then here you can see the title and write. It is just a front end thing to show people. And then here is the logic. So what I've done, I have allowed I've used st.file uploader. It is a Streamlit object that allows you to upload your files, very simple. And then I have simply told Streamlit that save the file, and then if the file is not none, please convert it into CSV using pd.read_csv function. Again used a button object of a Streamlit, which allows, and the label is predict. So whenever a user clicks on predict button, simply continued use of this functionality. Here, if user do not pass any CSV file, raise a simple error, uh, of course appealing, please upload your CSV, else go with like, for example, a person has uploaded the file and clicked on predict, then show file is processing, and then simply call all these methods that we have defined above, and one by one they are doing their job. Predict rating is giving the predictions, convert df is converting the output into a pandas data frame, download button allows you to convert your csv into a file, and I have given the file name as output underscore data.csv, and in the end st.success means and your file is ready. It's just it's just a message to show people like yes, the processing is now done. Coming back to here, you can find all of the things here mentioned. I have also added the readme and added the links that might help you out in the readme as well. So thank you so much everyone. We tried to build a Bitcoin transaction classifier that can classify whether a particular transaction is licit, legal, or illicit, illegal. Thank you everyone. Thank you so much.
Thank you, Muhammad. Very interesting and a bit different than everybody else. Um, Questions maybe from Denis or Lucine?
So how do you see this used in real life?
How do you use this in real life? Right now, I've shared the app link. You just have to share the app link with others. Like in my time, Facebook came, so we shared Facebook link or WhatsApp link to others. So you can share this link, and people can start using this app right in their browser, and this is just a beginning. Future steps can add more functionality to this application and the model as well.
And another possibility would be to implement this application in a coin exchange. So you can feed real life or real time data into the application in the right format. But if you are able to feed real time data into the app, you can directly measure if a transaction is illegal or legal.
Definitely.
Thank you.
Okay, thank you very much to both of you. Lucine, something from you?
No questions. All good.
Okay, then I thank you both. So what we will do now the jury will sit together. So I thank you guys. You can leave the stage.
Thank you once again
Thank
for
you.
the
Yeah,
opportunity, and thank you so
thank you.
much you for allowing us to express our ideas. Thank you very
Yes,
much.
you're welcome, and thank you for participating. Thanks.
Thanks.
So I suppose we're still streaming or not?
Yes, we still stream, but okay. So for the people watching the stream, we'll come back
Kuba, are we still
shortly.
streaming? Okay, so thanks everybody again for participating. The jury has had some interesting discussions on who will win or what we will do. And it's my pleasure to announce that the winning team is the team Next Convolution. You got beaten other teams by really small margins because all the solutions were really interesting, each in their own way. The prizes 1 and 2 will go to the team Next Convolution. It's a physical prize from AWS. So Dennis is just showing what your guys getting. So I hope you're happy about it. Then we have a second place, and second place goes for a really interesting and difficult data set and an interesting solution and thought process behind it. And this is the dear Data Phoenix lady from Chile, if I understand correctly. And you're also getting a prize, which will be Dennis, I think it's blue and it's your blue background, so I don't think you can see it.
Let me, if I show it in front of my yellow t-shirt.
Yes, that's good. So this is the prize for the Data Phoenix team. And to be honest, we were really maybe on different opinions who gets what second, third, and fourth place. And we decided that Team Data Unicorns and Team Latebirds get additional vouchers for AWS Cloud. So not only $25 as all regular users, but you will get additional vouchers. So you can really use and operationalize your data learnings. So thank you everybody for participating. All these informations we will post both on the DLL and on Swiss AI Association site. And yes, we will welcome you to join us on other events. In the meanwhile, I invite you to follow us on Twitter, check our website for interesting new events, and hope to see all of you again soon. Dennis, any last words from you?
No, but just want to say thank you for taking the time to participate. It's a great event. Good to see people coming from all sides of the world together and coming up with interesting solutions. Take them further. Don't leave them at just a hackathon space. Develop them and keep the good work for sustainability. Thanks, everyone.
Thank you, everybody, and see you soon, I hope. Bye-bye.